Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that specializes in supporting digital transformation of operations and businesses. Our guest today is Mohammad Afeneh, Bluetooth developer advocate at Bluetooth SIG. Bluetooth SIG, or Special Interest Group, is the standards organization that oversees the development of Bluetooth standards and the licensing of Bluetooth technologies. In this talk, we discuss new features being launched by Bluetooth, including long-range mode, high-speed mode, and mesh networking. We also explored the many uses of Bluetooth for direction finding, using angle of arrival and angle of departure. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iot1.com. Finally, if you have a business challenge and would like to discuss how IoT One can support, email me directly at erik.walenza@iot1.com. Thank you.
Mohammed, thank you so much for joining us today.
Yeah, thank you so much for having me, Eric. And I'm excited to represent the Bluetooth SIG here on this great podcast of yours.
I'm personally excited to learn what Bluetooth really looks like today, because I think, like probably a lot of our listeners, when I think Bluetooth, I still think mouse and wireless earbuds, kind of, right? I mean, these are the things that I've been using Bluetooth for many years, and of course now Bluetooth is much more than that, right? It's but I think a lot of the functionality is a little bit hidden, and it's also still in development. But before we get into that, Mohammed, I want to understand a little bit more where you're coming from. So I know that in addition to being the Senior Development Relationships Manager for Bluetooth in the Americas, you're also the founder of a company called NovelBits, which is also kind of very much oriented around Bluetooth. Can you just give us a little bit of background around, when did you start getting involved in the Bluetooth tech stack? What was your first touch point there?
I would say my first time really working with Bluetooth was back in 2014. I was at my a full-time job at a consulting company, and we did a lot of work for different clients in the different spaces, embedded, even desktop and enterprise level applications. But this specific project was on an access control system. In fact, it was the first Bluetooth-enabled door lock that supported, that was compliant with Apple's HomeKit. So it was kind of an exciting project. And I was still new to Bluetooth at that point. And it was pretty difficult in the beginning to kind of understand the technology, wrap my head around how to develop for it. So that was my first project getting involved. And then I had 2 other projects with that same company through my employer involving Bluetooth. Other projects were more commercial. One of them was a gateway that included Bluetooth for communicating with multiple door locks in a facility. And then after that, I think 2 years later, 2015, actually, mid-2015, I just had an idea of just leaving my full-time job and starting my own company. And at the time, I guess if I would go back and change something, I would kind of figure out things better before I quit my full-time job. But I actually ended up just quitting my job and starting NovelBits, not knowing exactly what I wanted to do at that point. I was trying different things, from developing software tools, and that was all on my own, to just learning about. And I knew that Bluetooth was kind of one of those technologies that really excited me from my experience on the last 3 projects at my employer. And so I really wanted to do something with Bluetooth, but I didn't know what. I started with development tools just for developers to help them achieve their job faster and develop faster. And then I came across an idea just from my past experiences with not really knowing where to start with Bluetooth, even though the specs are public and you can get free access to the spec, the full spec of the technology. It was very difficult to understand the spec, and I think it still is even at this point. But that led me to kind of try to connect with different people in the space. So I went out on LinkedIn and started interviewing different people in the space and trying to figure out what's missing. And I think I interviewed maybe between 75 and 80 people. And the recurring theme there was that there was a lack of training resources and education for engineers on getting started with Bluetooth and even continuing on past the beginner's phase to become an expert in Bluetooth in development. So that kind of gave me an idea to start just a simple blog where I just blog about the development of Bluetooth devices, even just me learning through more of the technology and just documenting this on my website. And it just started like that. And I was following other people, more prominent people in the other spaces, similar spaces such as AI and machine learning, computer vision. And they were transitioning more into not just blog posting, but also transitioning into writing books, developing guides and courses online. And that kind of enticed me, what you can do there to spread the knowledge with just the computer and just your internet connection. So that's really where Novel Bits kind of started. I started just blog posting, and then that led to writing a book on how to develop for Bluetooth low energy devices using Nordic semiconductor development kits. And that led me to also write a book, an intro to Bluetooth low energy book, which is available on Amazon as a paperback, but also downloaded for free through my website. And just a couple of years ago, I started to form kind of a connection due to kind of, I think, to the modest success of the website and Novel Bits. I started to form a connection with a few folks at the Bluetooth SIG, and that led to a contract position with them starting about 2 years ago. So I started helping in the same kind of role as what I am right now as full-time as a senior developer relations manager, but it was more of a part-time position. And the two kind of works, the two jobs, basically my full-time job that was for Novel Bits, my own company, and then the part-time job for the Bluetooth SIG really went hand in hand. And I saw that there was a lot more to do for the SIG as well, and to kind of help them in that way. So beginning of this year, in 2021, I actually switched to being a full-time position with the SIG. So that's my full-time work. Novel Bits, it's still ongoing. It's just something that I do in my spare time and on the side.
Yeah, well, it makes sense how you found your way into this role. I think that was really quite the find for Bluetooth to have somebody kind of as passionate and with as much experience writing, say, educational training material around this. So, Mohammad, Bluetooth has evolved quite significantly. Probably, certainly since we started using it, but also even since you started writing training for this, back in 2015, and it continued to evolve quite dynamically right now. Can you give us kind of a high level walkthrough, not really getting into the technical details quite yet, but just from a user perspective, what are the different use cases, the different device types that we might be using Bluetooth on today? And what are the different types of functionalities that it might be, providing for these different use cases? Just really from let's say more of a value proposition perspective, what does the evolution look like?
Yeah. So, I mean, as you mentioned, Bluetooth, people, when they think of Bluetooth, they usually think of audio streaming or peripheral devices such as mice and keyboards. But really, that was the initial kind of inception of Bluetooth in that space. But in 2010, Bluetooth Low Energy, which was a different standard than the original Bluetooth and still coexists with the original one, that's where really the innovation started. And that's where a lot of the new use cases and the excitement around new different devices on the market, such as, for example, Fitbits. If you think about fitness devices, any kind of small device that connects directly to your phone, most probably it will be using Bluetooth Low Energy. Those are the first devices that really utilize Bluetooth Low Energy. Medical devices started to adopt this technology as well. especially with being able to secure the connection and protect the data of users. But not only for just transferring data, but Bluetooth can also be used for device location and tracking location. So you can use Bluetooth, especially in the past couple of years with the new spec 5.1, direction finding capabilities were involved. So you can tell the angle of arrival or angle of departure of a signal at a device, at a Bluetooth device from the signal. And so that enabled more precise location tracking for devices using Bluetooth low energy. Some of the kind of unfamiliar use cases is that Bluetooth, especially when it comes to range, sometimes there's a lot of misconceptions with the range, and people think it's just 10 or 30 meters of range. But with Bluetooth in the last few years as well, some of the updates to the spec allowed it to increase up to even over 1 kilometer of range. And that's line of sight, obviously, but that still gives you an idea of what kind of use cases there. For example, controlling like a remote control for a drone from a distance, that can be using Bluetooth. But that same functionality as well, which is interesting for increasing the range, can be used in more congested areas just to make the connection more reliable. There's a lot of flexibility with Bluetooth and how it can be used in different applications. But beacons is as for tracking location and even proximity. That's kind of one of the most popular use cases that Bluetooth has been used in the past, as well as the fitness devices and medical devices.
I wasn't aware of the application for change in direction and so forth. Do you need multiple Bluetooth devices and you do kind of a triangulation, or is this just one-to-one and it can detect based on movement or based on the signal over time how the device is moving?
It is one-to-one, but it does require an antenna array on one of the devices. So if in the case of angle of arrival, the receiver will have an antenna array that can detect where the signal is coming from. Angle of departure is the opposite. The transmitter will have an antenna array that it sends the data from, and based on the antenna, adjusts some certain parameters in order for the receiver to receive that data and know where the angle came from, if that makes sense.
Gotcha. And what is the accuracy? I suppose this depends on the situation, but what is the rough accuracy that's achievable there?
It depends on the solution being used, but I've seen solutions that are sub 1 meter accuracy. If you increase the number of, just like triangulation, you could increase the number of stations or devices that are being deployed to make it even the centimeter level accuracy.
Okay, interesting. If we look at Bluetooth in the wider portfolio of connectivity solutions, and really now there is becoming quite a diverse array, what would be the key variables that you would use to compare what solution might be right for a given situation? And maybe you can also, I know Bluetooth has a few different flavors right now, so maybe you can also break that apart and look at which variation of Bluetooth might be right for a given circumstance based on the variable that you want to optimize for.
Sure. Yeah. So in terms of Bluetooth Classic, the original Bluetooth is what is referred to as Classic or BR/EDR. That is used mostly for streaming audio. So if you need something that streams audio in a very consistent manner, large amounts of data, then Bluetooth Classic is the go-to for now. And I say for now because upcoming LE audio will actually do exactly what Bluetooth Classic does and even more. But it's still in the coming future. Hopefully it's by the end of this year. So that for streaming audio right now, if you need to stream audio, you would use Classic Bluetooth or BR/EDR. Now, the other flavor of Bluetooth, as we call it, Bluetooth Low Energy, that's where there's a lot more flexibility there. With Classic, it's very limited what a device manufacturer or developer can do in order to customize based on the application that they're using it for. With Bluetooth Low Energy, you can adjust a lot of parameters. You can adjust the speed. There's different PHYs at the physical layer that you can choose to use to double the speed. For example, the highest speed is 2 megabits per second. That's the raw data over the air. So that gives you an idea. You can achieve up to 1.4 megabits per second, which is very high speed, and it's very useful for transferring large amounts of data, for example, a firmware update over the air. And then you have adjustment to accommodate for long range. The Bluetooth Low Energy is also the foundation for Bluetooth Mesh, which we'll talk about a little bit more even. And that's where a lot of the industrial applications can utilize Bluetooth. So Bluetooth Low Energy is really becoming the foundation for a lot of the new development in Bluetooth. If you think about it, Bluetooth Mesh is based on Bluetooth Low Energy. Bluetooth, the direction finding is also all low energy features that are introduced. And then in the future, LE audio is also based on low energy. So really you have two options, either Bluetooth Classic or Bluetooth Low Energy. And Bluetooth Low Energy gives you a lot more flexibility that you can develop profiles on top of the spec in order to achieve what you really want to achieve for your own application.
The profiles, are they developed, into the silicon? So they would be based on the hardware the manufacturer defined according to the required specs, or are they in the software, meaning that you could update them during the device lifetime?
They're in the software. However, there are two types of profiles. There are Bluetooth SIG adopted profiles, and those are ones that are there for the most common use cases, so that two devices that implement one of those profiles, we know can talk to each other regardless if they've ever tested their devices. So interoperability is the big thing there with SIG adopted profiles, but that doesn't end there. And those are implemented in software as well. But in order to qualify a device and to implement them, you can't change them. However, you can just go and create your own profile and services and implement them on the device. And that's all done at the application layer. And that can let you, it's the sky's the limit there with what you can do and customize it. And you're no longer restricted to only a certain number of profiles, certain number of applications, which was the case with classic Bluetooth. So Bluetooth Low Energy allows you the flexibility, gives you all this customization, and that's really where a lot of the innovation is happening. Is that manufacturers they have the flexibility. They know they can develop their own profiles and create custom what we call services and characteristics, which is really just the organization of the data being transferred between the two Bluetooth devices. And they can customize that to their own application, their own need.
Gotcha. And so if we look at Classic, as you said, it was defined for audio, so fairly high volume files, high data flow. If we look at Bluetooth Low Energy, I think a lot of people associate low energy with also kind of low bandwidth or limited data flow. What are the upper limits of what's possible? I mean, can you do high quality audio? Can you do video? What's feasible with Bluetooth Low Energy?
So it is changing. So that was the kind of the inception of Bluetooth Low Energy, is that the focus was on low data transfer over bursts of data, mostly not streaming data. The reason behind that was just to consume less power. That's where low energy comes from. But a lot of devices these days could also be live powered, and they don't need to conserve battery life, and they just run on live power, so they don't worry about that. And that's where, with LE audio coming, that will allow you to achieve even higher quality than classic, and that's due to a new codec that was released called the LC3 codec. And that allows you to achieve higher quality audio at even lower bandwidth than classic audio, than classic Bluetooth. So it's almost like it's in the future, we see that they're both going to coincide together for a while, LE audio and classic Bluetooth. But in the end, LE audio is going to probably overtake classic Bluetooth just because of its flexibility and the kind of applications that it brings with it. Some of them, the exciting ones, are like audio sharing applications. So you can, both 2 people or 3 people can be listening to the same source, or you can be at a bar at an airport and tune in directly with your headphones into a TV that's silent. And you can be listening to it directly into your headphones. You can switch languages. I mean, there's a lot of possibilities with LE audio, and that's all due to the fact that it's based on Bluetooth Low Energy.
Okay, fascinating. And you said did you say near the end of this year, or are these functionalities expected to roll out more in 2022, 2023? What would be a reasonable timeline there?
Yeah. So, I mean, there's things are changing. The core specification, which is Bluetooth 5.2, version 5.2, this was released last year, in fact, and it has all the foundation needed for the LE audio implementation. Some of the profiles, the one based on LE audio that allow you to, for example, in the end, buy a headphone from one manufacturer and be able to tune into a TV using LE audio that's from another manufacturer. Those profiles, the standard profiles, are still rolling out. Some of them have been released, but the expectation is towards the end of this year or the beginning of next year.
Okay, super interesting. Let's talk a bit more about Bluetooth mesh, because we are a bit more focused on the industrial side of the market on the podcast here. So what is Bluetooth mesh, a particular profile, or is this another technology entirely?
It defines a set of and the new standard on top of Bluetooth Low Energy. So it utilizes, so it can be actually implemented on any Bluetooth Low Energy device, as long as the stack supports it from the vendor. But it is based on the same hardware, so it does not need new hardware. It's more on the firmware side of things. And it does define some profiles, which are called models in the case of Bluetooth mesh. But that's also flexible, and manufacturers can define their own models on using Bluetooth mesh. The original Bluetooth mesh, when it was released, and most of the models focused on the lighting controls and lighting systems. And that's due to one interesting fact, is that lighting was seen by the Bluetooth mesh working group as one of the easiest ways to get into a building or being a part of the infrastructure in a building or in a facility or in a factory. And that's because LEDs are replacing the fluorescent and halogen lighting in a lot of these buildings to comply with building and regulation codes. But at the same time, an LED can be smart and can already includes electronics and is much easier to incorporate a Bluetooth chipset into. And so that lays kind of a foundation. And that's what Bluetooth mesh comes in and provides that foundation in order to then start with the lighting system in a facility, and then be able to connect even more sensors and gather even more data from the facility and a manufacturing plant, or whatever the application would be.
Before we get too much into the details here, our audience is a mix of some people that are quite technically sophisticated around this topic, and some that are really coming from the business side, for whom this is an interest, but not necessarily their day job. Can you just explain how mesh networking works, and then we can get into the different applications. But before we get into the details, just give us a high-level explanation of how mesh networking works.
Yeah. So mesh networks in general, it means that a group of devices are part of the same network. But in order for one device to communicate with another, it does not have to be in direct radio range of the other device. It can relay devices in the middle between those two communicating devices can relay messages to each other. Now, Bluetooth mesh is a little bit different than other mesh networks based on other technologies, in that it uses a technique called managed flooding. So there's no centralized device or node within the network. And so that allows it for no single point of failure, and it's fully distributed. So you can remove devices and add devices as you want. And it does not rely on the two devices at this point, Bluetooth devices, to be connected to each other, because that limits kind of the communication between them, but rather everything is listening and broadcasting at the same time. And then there's also support for low power nodes. Those nodes will, in order to conserve power on these nodes, they will be paired with what's called a friend node within the network. And that friend node is the one that caches messages for the low power node, so that it can go to sleep more often and only wake up certain amounts of time and ask the friend node for any messages that it needs to receive, or send any messages through the friend node. It's also designed to be highly scalable, up to over 32,000 nodes in a network, compared to some other technologies that supports only in the thousands or under 10,000, sometimes even hundreds. It's also low power. That's achieved through the low power nodes as well. And I think the biggest really pro for Bluetooth mesh compared to other technologies as well is that it is very simple to commission, and that's done through an app on a smartphone. So whereas with other technologies, you usually don't have, with low power technologies, there's not a lot of support on smartphones. So you need a specialized device, and that in order to communicate or commission a whole network in a facility. Whereas with Bluetooth mesh, the mesh supports what's called a proxy node that allows a smartphone to communicate with one specific node in order to commission the whole network. And just having an app on a smartphone just make things a lot more familiar to a person who's commissioning and deploying a Bluetooth mesh network. But it also makes the cost less compared to having a specialized device or somebody with specialized training in order to achieve that same functionality.
Okay, and if we look at the different applications or use cases for this, I suppose, at least the way I'm thinking about this, there might be three big clusters. There would be this triangulation or location and velocity of moving objects. Then there might be also industrial situations where you have a lot of metal and a lot of walls, and you need to make sure that you have constant connection. So mesh would enable you to have a much more reliable connection in this type of environment. And then you could also have, I guess, the third category that I'm thinking of, at least, farms, forests, wide areas where you have a farm, you have a farm somewhere that has connection to the internet, and then you want to get connectivity out to sensors that are in the field that might be dozens of kilometers away. So the mesh would allow you to bridge over to those. Is that a reasonable way to think about this, or how would you categorize the primary use cases here?
I think the primary use cases with mesh at this time will be more for indoor applications rather than outdoor, just because unless you have the ability to have live power at each of the nodes in order to be able to transmit messages a lot faster. It depends. If you're only looking to transmit data and at small bursts and very infrequently, then I think outdoors would work. But in the end, I think that the biggest implementation or the biggest place where Bluetooth mesh would serve the best is inside buildings, and starting out with the lighting system and replacing the luminaires with Bluetooth mesh devices, light bulbs or LEDs that support Bluetooth mesh, and creating that infrastructure that allows you to then extend into like sensors, tracking objects on different objects within a facility, or even monitoring machinery through monitoring different parameters such as temperature, humidity, and relaying that through the mesh network. But having the live powered nodes that are in the LEDs gives you, I think, the best way to implement a network at a cost-effective manner that allows you to achieve even more, not just automated control of lighting or smart lighting.
Gotcha. Talk to me quickly about standards. So, this is a topic that is maybe not the sexiest topic and maybe not so familiar to a lot of people, but something that is actually quite important, especially when we talk about industrial settings. I know there's a very wide variety of manufacturers that are building the hardware here, and then these devices ideally should all communicate with each other. What does the evolution of the standards look like, and where are we today in terms of kind of alignment on the standards?
Yeah, so as you mentioned, industrial is very different from consumer, and decisions are made much more carefully. So I know standards and specs are really very important in the industrial use cases, and that's to ensure that there's interoperable solutions or devices from different manufacturers can work together. With Bluetooth Low Energy, that's already there, and everything is any Bluetooth device that implements a certain profile needs to get qualified before it can be considered a Bluetooth compliant device. So that allows and that makes sure that two Bluetooth devices implementing one of the SIG adopted profiles communicates with each other and is interoperable. And Bluetooth mesh is kind of in the same space. It's based on Bluetooth Low Energy, but the qualification is not yet 100% there. There are certain models that are being qualified at this time. Those are already qualified and they can be qualified. But then if you go and implement your own models, there's also some customization there. So you can't 100% guarantee the compatibility between the two devices. But it is getting there. And this is where a lot of the work is being done.
Gotcha. And then there's one other topic that we don't like to think about until it hits us in the face, which is the topic of security. And this has been in the news, a lot more than we would have liked lately. But what is the security profile of Bluetooth? Does the connectivity solution play an important role in securing the devices, or is it other software on the chip that's securing the device?
With Bluetooth Low Energy, the standard, it defines what different security levels for manufacturers and developers to choose from, just based on the application that they're working with, based on the level of importance of how much to protect certain types of data. So there's flexibility there. With Bluetooth Mesh, security is mandatory. There's no way. There's different levels of security. There's different devices that can understand or decrypt the data that's meant for them and not for other devices, not for other devices. So, for example, if you have a key switch or a light switch that needs to control a light bulb, then you don't want some other device such as a smart lock to be able to decrypt messages that are going between those. So there's different level of encryption and authentication between devices, and that's all mandatory with Bluetooth Mesh. There's also network keys that allow just messages to be within the network and understood by all devices within the network, but not being able to be decrypted by outside. And that all uses encryption and methodology using elliptic curve Diffie-Hellman authentication, which gives it a lot more security than other solutions.
Okay, well, I have no idea what that is, but I guess if anybody's interested, you can Google that. We won't go in detail here.
Yep.
Mohammad, can you walk us through one or two use cases of how Bluetooth low energy, or maybe ideally Bluetooth mesh, is being used today?
So as I mentioned, the lighting systems is one of the most popular for Bluetooth mesh at this point. There's a lot of examples of that out there. I think there was an example that I saw where there was a Bluetooth mesh network that had over, I believe it was 17. It covered 17 floors of an office building and had over 3,000 nodes just within that same mesh network, and it was all working reliably. There's also different applications, not necessarily using mesh, but the asset tracking applications that are being used. I know, for example, you spoke with somebody from Tom from Coupa, I think, recently, and that kind of application uses Bluetooth. And asset tracking is a big application, or a very major one, within the industrial space. For example, there's a company called InPlay recently that is a provider of wireless system on chips based on Bluetooth that achieve ultra low power and low latency, and they're designed for scalability. They had a client of theirs, a company called Shanghai Advanced Avionics, and they implemented a management for thousands of assets using beacons, using InPlay's Bluetooth-enabled solution that allows bi-directional real-time communication between the base stations and the nodes within that system. InPlay was able to provide a system that satisfied the requirement for that asset management system. And some of the challenges that they had was achieving real-time communication, which I believe InPlay's own implementation ensured that, leveraging the fact that Bluetooth supports low latency communication. And then the cost of Bluetooth beacons is pretty low, also because they can run on smaller batteries for longer periods of time due to utilizing Bluetooth Low Energy. And that also, because of the range of Bluetooth introduced in Bluetooth 5 just a few years ago and achieving longer range, it requires minimum number of base stations as well, which reduce the cost. And then for security, data authentication and encryption over Bluetooth is possible, and it's defined by the spec and can be implemented at the different levels depending on your application that you're using it for.
Gotcha. For me, the device tracking application is quite intuitive, right? So you know, people want to track devices for many different reasons, but you can imagine, you know, the need there. Can you explain a bit more the value proposition behind the mesh network for lighting? So to some degree, I guess people are comfortable turning on and off lights. So what is the value proposition about connecting 1,000 lights across 17 flights of stairs and having those all part of the same network?
Yeah. I guess some of the few aspects where Bluetooth mesh is different than others is that, first of all, the being able to commission the network in a much easier way and control it from a smartphone, whereas other technologies are not supported on smartphones in general. Bluetooth Low Energy, which is the base for Bluetooth mesh, is widely supported. In fact, it's even supported on 100% of all smartphones being produced from now and into the market. Some of the other pros of Bluetooth mesh and is the low complexity, and the implementation of Bluetooth mesh also is in the standard is defined all the way up to the application level, which is different than other technologies where you have to define your application level yourself or define models yourself and rely on that being relayed to other manufacturers for other devices that are to become interoperable. So interoperability and global interoperability is really a big deal and is really important and achieved with Bluetooth mesh. The reliability with no single point of failure and the system being fully distributed, and also the security. I mean, with the mandatory security and being able to remove devices and add devices, and even making sure that those removed devices they don't compromise the security of the network. That's also achieved by handled in the Bluetooth mesh, where you can refresh the network keys on the devices after you remove a device or a device gets lost or something. There's a lot of other ones that you can think of that give it really an advantage over other networks in the Bluetooth as an application of Bluetooth mesh.
Okay, gotcha. Mohammad, one last question from me. We've talked a lot about the functionality as it is today. We've also talked a bit about what's around the corner in the next year or so. I was asked recently to help a company think through what 6G might look like from an IoT perspective, and this is a bit of a stretch because we're just starting to roll out 5G. So what 6G might look like is kind of an imagination exercise to some degree. But I want to ask you this question. So what would Bluetooth 2030 look like if you're looking forward 10 years into the future and you're thinking, based on your experience, what would be the functionality that might be rolling out in 2 or 3 generations of the technology? What would be most exciting for you to see from Bluetooth in the next decade?
Yeah, I mean, no technology is like one size fits all. So I don't expect Bluetooth to do everything under the sun. But I mean, some of the things that I'm seeing and I could see, I mean, nobody expected even Bluetooth to do LE audio. So audio over LE a few years ago, nobody would expect that. But if I stretch my imagination, I would see Bluetooth being used more in even in video streaming and be able to use to stream video between Bluetooth devices. I see a lot of innovation happening in the hearing aid space with Bluetooth and maybe hearing aids converging into the term hearables is being thrown around a lot these days. And it's just referring to the fact that hearing aids are converging with earbuds and personal listening devices. So I see Bluetooth making a big change and difference in the healthcare industry from that aspect as well. Imagine a lot of the people who have hearing loss being able to just use regular Bluetooth earbuds to listen directly to sources of audio rather than having to go get a specialized device that costs hundreds of dollars in order to achieve that. So there's a lot of applications. definitely one of the things that interests me the most as well is just in technologies in general coming up is AI and machine learning, especially when it comes to implementing them at the edge and on embedded devices. So I can see in the future Bluetooth devices, small Bluetooth devices such as hearing aids being able and earbuds being able to process and do a lot of these complicated and complex applications from AI and machine learning at the device themselves without even requiring a connection and reducing a lot of the bandwidth. So that opens up a lot of space as well for what you could use that bandwidth for now that you don't have to utilize it for a lot of streaming of a lot of data.
Yeah, no, excellent point. Cool. Well, yeah, I'm sure we'll have another decade of innovation ahead. This is certainly, this train is not stopping. Yeah, I think we've had a pretty comprehensive conversation. I'm just wondering if there's anything we missed, but maybe we've covered most of the key points here. We've
covered a lot. There was a lot of interesting application, I guess, from the last year since because due to COVID, I'm not sure if you were aware that Google and Android and Google and Apple came together and created this exposure notification system. And that was also based on Bluetooth Low Energy and using Bluetooth between devices to detect your exposure to somebody who contracted with COVID. So that was kind of an innovation that happened, when nobody expected COVID to hit. Nobody expected something like that, a pandemic, to happen in 2020. But it's kind of exciting. It's exciting to see that technology like Bluetooth can be used even in situations that are like this in order to solve a problem that's happening in real life. There's a lot of interesting ideas, I think, that could be solved with technology. And Bluetooth, I think, is one of those technologies that have proven to withstand the test of time. Right. Well, necessity is the mother of invention, right? I feel like everybody I have on the podcast has some story about how COVID has kind of helped to push forward the development of their technology by 24 months. It's kind of a terrible situation, but in some ways it's certainly pushed people to innovate. That's certainly the case. Great. Well, Mohammad, really a pleasure to meet you today. Thanks for taking the time to speak with us. If any of our listeners are interested in learning more about Bluetooth or connecting with the community, what's the best way for them to do that? Yeah, definitely on the Bluetooth.com website. So Bluetooth.com, the Bluetooth SIG website, we have a lot of resources, whether it's educational from a business point of view, a high level, or even down to developing and coding. We have study guides that are available to download. There's a lot of educational material on there, and we're expanding. My team is expanding into different ways to spread the knowledge as well, and looking at different mediums to be able to educate people and increase awareness on Bluetooth. Excellent. Well, Mohammad, we are just kicking off now IoT One Academy in collaboration with a partner in Germany. So maybe we can touch base offline, but I would love to learn how we can also get some appropriate information on there. Yeah, absolutely. Well, Mohammad, thank you again. I really appreciate your time. Thank you, Eric. Appreciate it.
Thanks for tuning into another edition of the IoT Spotlight podcast. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iot1.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.walenza@iot1.com. Thank you.